Hello class, Dr. L here again. I'm going to go over problems 5.1, 5.3, 5.5, 5.7, 5.9, 5.11, 13, and 15 from the Fundamentals of Corporate Finance 3rd edition text. As with previous chapters, you all have the answer in the back of the book, but the question is going to be how do you get to that answer? And that's the key, because as you all know from this point, if you don't have a formula connected to your cell, you're not getting credit for that question. So let's get started. Question 5.1 reads, future value. Chuck Tomkovic is planning to invest $25,000 today in a mutual fund that will provide a return of 8% each year. What will be the value of the investment in 10 years? So let's unhide this. Oh, these two. So we have the given, right? As you remember from previous videos, always try to isolate the given. This is a word problem. You want to untangle this and try to figure out what it is that it's asking you. So we have the present value of the investment, we have the rate of return per year, we have the term, which is 10 years, and then we have the compounding per year. If you remember, if you had a chance to look over the chapter 5, it talks about compounding. So it goes a little bit more in depth. I'm not going to go over that in the video because in this video is very specific to getting to the problem, getting to the solution for the problem. The bottom line here is that we're just trying to figure out what the future value of the initial 25,000 will be in 10 years, period, right? So the first step is try to look up the future value formula in your text and understand what components are made up of that future value formula. So when I was going to school, I learned how to use the Texas Instrument BA2 Plus business analyst calculator. So I don't know if you all have the business analyst calculator. If you do, I mean, I can totally show you how to do the problem on the business analyst calculator, but Excel already has the functions in it, so I don't think it's necessary to actually learn that for the purposes of this class and this exercise. So the easiest thing to do is just to use the Excel FV formula, which is the future value formula. Okay, and when we do that, the future value comes up to $53,973.12, which yes is consistent with what's in the book. So now if you look at the future value formula, let's see what it consists of, right? It consists of all the information that's right here. So let's try to do it here on the side so you can have a better understanding of what goes in it. So let's see. So we know future value, right, equals the rate, which is 8%, the number of periods, which is 10. Payment is going to be 0, and the reason why that is because normally you're going to be using payment when we get into bonds. So you have to put something there. So payment is going to be set to 0. So, but don't let it confuse you, right? And then the present value, you're gonna make it negative this because it's basically money out. All right, so let's try it over here. Equals present value open parentheses. So then it's asking you for the rate, which is this, the number of periods, which is that, the payment we said it was gonna be 0, right? Oh, I just used the present value formula. Whoops. Don't make that mistake. So it's future value, FV, open parentheses, right? The rate, comma, number of periods, which is 10, comma, payment, we said it was 0, comma, and then the present value, which is going to be a negative that, 25,000. And then, yep, we get the same answer. So that's how you come up with the future value, okay? So now let's move on to problem 5.3, which is another future value problem. Your aunt is planning to invest in a bank deposit that will pay 7.5% annual interest compound semi-annually. Okay, that's a key word here. If she has $5,000 to invest, how much will she have at the end of 4 years? So let's isolate the given. The present value. Oh, by the way, you guys don't have to copy like all this stuff that I do. Like this is just for me to help you understand like how to untangle what's in here, but you can totally just put like 5,000 or like 7.5% or like whatever. It doesn't have to be in the same format that I do it. So you don't, if it helps you, power to you, keep doing it that way, but if you don't need to, that's fine. All right, so the given present value of the investment is 5,000. The interest rate per year is 7.5%. The terms, or the N, if you're using the business analyst calculator, is 4, right? And the compounding frequency is 2. Why 2? Because it compounds semi-annually. Remember, we said semi-annually. So semi-annually means twice a year, okay? So the bottom line is that we need to find the future value. That's it. So let's unhide this. So look up the future value formula in your text. The easiest thing to do is just, like I said, use the future value formula in Excel. If there are 4 years and it compounds twice a year, then that means that there's 8 periods. All right, so that's important to know. If another tip is that you need to find out what the adjusted rate is. So the way that the future value formula is going to look like, let me zoom out here a little bit, is going to be the rate divided by 2, because we need to know what the rate is for each compounding. Then the term, which is 4, times the compounding frequency, 0 for the payment, and then a negative present value. All right, so let's unhide this. And then you get for future value, you get 6,712 and 35 cents, which coincides with what's in the back of the book. So let's do it here, following these steps that I provided here, right? So let's do FV equals FV open parentheses. So then the rate, let's do it here. The rate is this, the interest rate per year, and then we said divided by 2, comma. The term for the number of periods, it's the term times the compounding frequency. So the term times the compounding frequency, which is 2. Now for this future value, present value kind of stuff, you don't have to open parentheses, close parentheses, all right? So that's kind of different than what you're probably used to in Excel. Comma. Now it's asking us for payment. Payment, what do we say it was? Always 0. We're going to deal with payment when we get to the bond section of the text. And then the present value is 5,000. Negative present value. Why? Because it's money out. So let's make this negative E8. And you don't really have to close parentheses, just hit enter. And when you hit enter, you get the answer. You see? All right. So now let's move on to 5.5. 5.5, another future value question. Your bank pays 5% annual interest compounded semi-annually. This is a keyword right there, right? On your savings account. You don't expect to add to the current balance of 2,700 over the next 4 years. How much money can you expect to have at the end of this period? So let's isolate the given. We know that the rate of interest is 5%. We know that the current balance is that you owe is 2,700. Owe is a keyword, okay? Owe means that money out. Term is for 4 years, and the frequency of the compounding per year is 2. Why 2? Because it's semi-annually. That's why. It's not going to tell you it's compounded twice per year. It's going to say semi-annually, and you just have to remember that semi-annually is 2. The bottom line is that we need to find out the future value of this savings. Don't let the verbiage confuse you. So look up the future value formula, and in this case, what we're going to do is the future value equals, and this is kind of like the Excel formula written out as a sentence, which I think might help some of you. So we do the rate of interest divided by the frequency of the compound, comma, term times the compound, comma, 0 for the payment, comma, and then present value. The present value is already a negative because it's in parentheses. So we're good. We don't have to make it a negative, all right, when we do it. So now let's solve. And when you do it, the future value comes out to $3,289.69. And let's do it here on the side. So equal FV open parentheses, right? We said it was the rate of interest, which is 5%, divided by the frequency of the compound, 2. Why 5% divided by 2? Because we need to get we need to tell this formula that it's not compounding just 5%, it's compounding 2.5% per half year. Okay? Let that sink in for a sec. So it's actually 2.5% compounded every 6 months. All right? So the rate is going to be the rate of interest divided by the compound, comma. The number of periods is going to be the term times the compound, because in total it's compounding 8 times. All right. And then the payment is asking us for payment. We said it was 0. And then the present value, we just click here and it's already a negative. And if we widen this a little bit, we get the same answer, you see? All right, 5.7. Multiple compounding periods. Find the future value of a 5-year, $100,000 investment that pays 8.75% and that has the following compounding periods. So this is a 4-part question. Quarterly, monthly, daily, continuous. Not hard. So let's isolate the given. We know that the investment was 100,000. That's money out. 100,000. That's why it's negative. Money out. Okay, remember that. Money out, negative. Interest rate 8.75. That's given from here, and the term is for 5 years. All right. So now what we're gonna have, if you don't notice, what we don't have here is the compound, and that's what we're trying to solve for, right? So here's a couple tips. Quarterly means that it's 4 compounding periods. Monthly means that it's 12 compounding periods. Why? Because there's 12 months in a year. Daily means that it's 365 compounding periods. Why? Because it's 365 days in a year. And then continuous is tricky. I wrote tricky wrong. It's tricky, but we just have to use whatever big number. So for the purposes of this example, the textbook uses a million. So we're just using that. So, this could be a continuous, like, hourly compounding or minute compound or whatever. But we're just using a continuous number that's bigger than 365. So let's unhide this. Now we solve. So we have to solve first for quarterly. So the future value if compounding quarterly is this, right? We already explained how to separate it when it compounds various times per year. So we do the rate, which is going to be the interest rate divided by the number of the compounds, which is 4. Okay, comma. The number of periods is going to be the term times the number of compounds, which is 4, comma, 0 for the payment, comma, and then the present value, you just click here, 100,000, and then you press enter. And when you press enter, you get $154,154.24. Okay? Now let's solve for B. If we're compounding monthly, remember monthly is 12. Okay, so this one is done. We don't have to look at it anymore. Right? Let's just put it like in that color. Monthly means that it's compounding 12 periods. So let's do it for that. We do equals future value FV, open parentheses. So then for rate, we're going to do the interest rate divided by 12. Just type out 12. Why 12? Because it's compounding 12 times in a year, monthly, comma. Then for the period, we're going to do the term times 12, comma, 0 for the payment, comma, present value is going to be 100,000. And then when you click enter, you get your answer, and that's 154,000. $637.37. All right. Now we solve for daily compounding, which is a little more, right? Now you're noticing a trend, right? The higher the number of times it compounds, the higher you'll end up owing, or the higher the value if it's a savings account. So something to keep in mind when you open like credit cards or whatever, it'll tell you in that very fine print what the compounding rate is, and you can actually calculate that. So when you go to Target and they tell you if you want to save 10% by opening a credit card, you might end up paying a lot more than 10%. So of course they're going to give you the discount right away. Anyways, so future value of compounding daily. We do the future equals future value, open parentheses, and then the rate is going to be 8.75% divided by 365. Why? Because it's compounding 365 times in a year. Comma. For the number of periods, we'll do the 5 years, so you click 5 times 365, because in total, if it's compounding daily, that's 365 days times 5 years, all right? Comma, 0 for payment, we already explained why, comma, then your present value, which is 100,000, when you click enter, or you hit enter, it's $154,874.91, and that is your answer. So now let's do the tricky one. All right, so this is done. All right, so now let's unhide this. All right, so that's my reminder to my videos, which I'm doing now. I'm on time. All right, so future value of compounding continuously. Remember we said we're going to use a million only because the textbook uses that to get to the answer that's in the back of the book. But really, you can use like any number, so it won't be marked terribly wrong if you use whatever. But just use a million, all right, for now, for the purposes of getting of this answer matching what's in the book. So what we do is we do equals future rate, future value, open parentheses, and then for the rate we're doing 8.75% divided by a million, comma. For number of periods, we're doing 5 years, so you click 5 times a million, right? For a million compounds, comma, 0 for payment, comma, and then you click negative 100,000 for the initial investment. And you'll get your answer from the back of the book, which is $154,883.03. All right, moving on. Question 5.9, present value. Roy Gross is considering an investment that pays 7.6% compounded annually. Right, compounded annually. How much will he have to invest today? Invest today, money out, right? This is the money out. Roy is going to have money out. Such that the investment will be worth $25,000 in 6 years. So we have the rate of return, which is 7.6, the term, which is 6 years, right? And we have the terminal value, which, or future value, don't let the verbiage confuse you. Terminal means end value of $25,000. So this question is just asking for the present value. So I put a note here that since we're gonna deal with a negative somewhere because this is money out. So we're saying how much money does Roy have to be out of today in order to make this 25K in 6 years. So we need to find present value. That's in the Business Analyst Texas Instrument BA2 Plus calculator. You can do this also, but we're using Excel here, right? Because it's easier. Why make your life more difficult? So what we do is we do equals negative present value, open parentheses. It's going to ask us for the rate, so we click on 7.6, comma, the number of periods, which is 6 years, we click on that, comma, 0 for the payment, comma, and then the future value, which is the same thing as terminal value, that. And then when you do that, you get 16,108 and 92 cents. Okay. And let's do 5.11 now. Present value. Your brother has asked you for a loan and has promised to pay you $7,750 at the end of 3 years. If you normally invest to earn 6% per year, how much will you be willing to lend your brother if you view this as purely a financial transaction? In other words, you don't give your brother a special deal for being your brother. So let's isolate what we know. The expected rate of return is 6%. The term of the loan is 3 years. And the future payment to be received is $7,750. So what is this asking you? It's only asking you for present value, all right? Big tip, it says it right here. So let's go ahead and solve. So now the question again is, how much will you be willing to lend your brother money out, right? And what do we say about money out? Money out is negative. So it has to make sense. Like it's asking for the present value of the quantity that you're going to lend your brother today. So just keep that in mind when playing with negatives and non-negatives, all right? So you do equals negative present value, open parentheses, and then the rate is gonna be 6%, comma, the number of periods is 3 years, comma, payment is 0, comma, and then the future payment to be received is 7,750. So think about this for a second. The future payment to be received is money in that's a positive for you. So we're trying to figure out how much money out. Like it doesn't. This question could not. Maybe it wasn't phrased that your brother has asked you for a loan. Maybe it was that you were making an investment period. So don't let these word problems confuse you. So you do negative present value because that's it's money out. Okay, and that's what we're trying to solve for, and the answer comes out to $6,507.05. So then, if we're looking at a rate of return of 6% over a period of 3 years, and at the end you're hoping to get $7,750. The amount that you should be willing to lend to your brother is this amount, the 6,507, and then you'll get your 7,750 back if your brother pays you back. All right, 5.13, present value. You want to buy some bonds that have a value of 1,000 at the end of 7 years. The bonds are set to pay 4.5% interest annually. How much should you pay for them today? So it's just asking you how much money out you're willing to pay today. So I use these terms, money in, money out, very colloquially, so you won't really find them in the textbook. It's just my way of trying to give you like some logic behind why questions are the way that they are. Future value of the bonds, we have 1,000. Maturity of the bonds, which is, this is basically just periods, the number of periods. The rate of interest is 4.5%. This is another present value question. It's just asking you how much money out you should front today, right? So let's unhide. So the present value is $734.83. And the way that we get to that today is, again, just like the previous question that we talked about, 5.11, it's money out. So we do equals negative PV, open parentheses. For the rate, you just click on the 4.5, comma. For the number of periods, just click on the 7, comma, payment 0. Even though I had said previously that we're going to deal with payment when we deal with bonds, it's actually from the other person's perspective. So if you were a bond issuer, how much would the coupon payments be? That in that manner, we are going to deal with payment, but not yet. So you do 0 for payment still, comma, and then the future value is 1,000. And then when you do that and you hit enter, you get your $734.83. The last problem that we're going to go over is problem 5.15. This is an interest rate problem, so this is what we're going to solve for. You are in a desperate need of cash and turn to your uncle who has offered to lend you some money. You decide to borrow 1,300 and agree to pay back 1,500 in 2 years. Alternatively, you can borrow from your bank, which is charging 6.5% annually. Should you borrow from your uncle or should you borrow from the bank? So let's isolate the facts. The amount being borrowed from the uncle is 1,300. The period of the loan is 2 years. The amount to be paid back to your uncle is 1,500. And the rate of the interest that the bank loan is charging you is 6.5. So the question is just asking you to compare interest rates. So since we know that the bank's interest rate is 6.5%, what we're really trying to do is to find out what your uncle's interest rate is. So to find your uncle's rate, Excel has a formula called equals rate. So it's kind of similar to PV and FV, what we were doing before, but you go equals rate, and you see that when you do open parentheses, it starts to ask you for its conditions. Unhide. All right. So in order to solve for this, we do equals rate, open parentheses, and then we do the number of periods. So we click on 2, comma, then it asks for payment, which is 0. So don't get this confused on the payment that you owe the person who will let you borrow the money. It's gonna be 0, comma. Present value is negative F8. Oh well, negative 1,300, right? Because although it's borrowed from your uncle and it's plus for you, you owe that back to your uncle. So we're doing that as a negative, comma. Future value. Okay, and then when we do that, we press enter. The rate that the uncle is charging you is 7.42%, and the bank is charging you what? They're charging you 6.5%. So what are you gonna tell your uncle? If the bank is giving you 6.5%, you tell your uncle to go whatever you want to tell him to in a very nice way, and let him know that you're going with the bank's rate because the bank's rate is cheaper than the rate that he's charging you. This concludes a few tips for Chapter 5 from the FIN 3400 from the Fundamentals of Corporate Finance 3rd edition text. If you have any questions, comments, or concerns, please feel free to email me and I'll be more than happy to assist. Have a great day.